Hey guys, welcome back to the channel once again. In this video, we are going to discuss some questions which appeared in the evening shift of Jan 28th JEE Mains exam. Alright, so we are going to pick some good questions and we are going to solve them. The aim of the video is not just solving the questions but to show you how some concepts, some good concepts can be used in the questions and you know and beautiful questions can be made in the exam. And also I'm going to show you some questions where you can avoid lot of calculations and make use of some properties or something of that sort. So this video is going to be a good video, so make sure you watch till the end. So let us start with the first question. So there was something like this in the exam. So f of x is given, so this is 1 minus 2x plus integral 0 to x e to the power x minus t f of t dt. So this is one function given to us and x belongs to real numbers. So x belongs to real numbers. And also there is one more function in the same question. So this goes something like this: integral 0 to x f of t plus 2 whole power 15 and t minus 4 whole power 6 and t plus 12 whole power 17 dt. And even here x belongs to real numbers. So this was the question that was there in the integer section of the question paper. So what is given? So it is given that p is the number of points of local minima. Number of points of local minima, and q is number of points of local maxima of g, of the function g. And we had to find out the value of p plus q, mod p plus q. The question goes something like this. So the reason why I have chosen this question is because we are going to use a very beautiful concept here, the concept of wavy curve. I've chosen this question also because this concept is very important for your JEE advanced exam. So lot of very good questions appeared on JEE advanced exam which is based on this particular concept. Alright, I have already made videos on those questions and I'll be leaving the links to those videos in the end screens. Make sure you check them out. So now let us go ahead and solve this particular question. Okay, so the important step in wavy curve method is to find derivatives of the function. So find the derivatives. Alright, now since they are asking about the local minimum and local maximum of g of x, so let us consider this part. So what is the function? So g of x, so let me rewrite that, is equals to integral 0 to x, alright, f of t plus 2 whole power 15 multiplied by t minus 4 whole power 6 multiplied by t plus 12 whole power 17 dt. So if you observe, the entire thing, the integrand is in terms of t. So you can use the Leibniz rule to directly differentiate this. G dash of x is, so you'll be putting x in the integrand first, so that will give you f of x plus 2 whole power 15 multiplied by x minus 4 whole power 6 multiplied by t plus 12 whole power 70. After putting x, you have to multiply this with the derivative of x, which is 1, minus, now you have to put the lower limit, which is your 0. So that is simply f of 0 plus 2 whole power 15 minus 4 whole power 6 and 12 whole power 17, and then you have to differentiate the 0, which is 0. So this term goes to 0. So I wrote this just to give you an idea that if there is another function, let us say root x here, so you have to put root x and then multiply it with the derivative of root x. Understand? So now this is our g dash of x. All right, now since we have the term f of x here, all right, we have to find out what f of x is. So let's do that. How do we do that? So let us go here. What is the equation given to us? So it is given that f of x is 1 minus 2x plus e to the power x. Sorry, it is integral 0 to x e to the power x minus t f of t dt. Even here the thought is to, the idea is to find out f dash of x. When you find out f dash of x, you will have to differentiate this integral. So the reason why I have chosen this question is to explain a very famous misconception that the students might fall into. All right, that is a trap. So if you see the function which is there inside of it, so this is not in terms of t completely, there is an x term also inside the integrand. So when you have something of that sort, you cannot go and differentiate it directly. You cannot put the upper limit and then differentiate the upper limit, just like how we did for g of x. Since we have this x term here, so we should only have t terms inside the integrand. This is the mistake that a lot of students make while applying this thing. So before proceeding to differentiating it on both sides, what we will do, since the integral is with respect to t, we can bring out this e to the power x and integral 0 to x e to the power minus t f of t dt. Explaining this step is the only reason why I have chosen this question. This is a very, very, common mistake that most people will do and end up solving the questions incorrectly. All right, now go and integrate this f dash of x. Differentiate this f dash of x. The differential of this is 0 and the differentiation of this term is minus 2. Now here we will have to apply the product rule. So e to the power x I'll write as it is, and now we'll have to differentiate this integral. How do we do that? Put the upper limit and differentiate the upper limit, which is 1, minus put the lower limit and differentiate the lower limit, which will be your 0, plus now the integral will stay same, e to the power minus t f of t dt. You have to differentiate this, which is e to the power x. Now what we can do, so this e to the power x multiplied by this whole integral can be replaced with f of x minus 1 plus 2x. So your f dash of x is minus 2 plus here e to the power x into e to the power minus x will be 1. So this is simply f of x plus this thing can be replaced with f of x minus 1 plus 2x. So this is f of x minus 1 plus 2x. Alright, if you say your f of x is y, so this is your dy by dx. This is equals to 2y plus 2x minus 3. Alright, this is what you have. So dy upon dx minus 2y is equals to 2x minus 3. Now you have to find the integrating factor. What is your integrating factor? Integrating factor will be e to the power of minus 2 times dx. So this is simply e to the power minus 2x. So when you multiply it with integrating factor on both sides, okay, this left hand side will be d by dx of y into e to the power minus 2x, and your right hand side is same, whatever you have here. So now integrate it on both sides. When you integrate that, your left hand side will be this thing and your right hand side will be integral e to the power minus 2x multiplied by 2x minus 3. Alright, now here you have to apply by parts. There is no other way. Alright, I think you will be able to do that. So you have to apply by parts here and find out what y is. So when you solve that, you will get y is equals to 1 minus x. So therefore f of x is equals to 1 minus x. This is what you'll get. I have not solved the by parts part. Okay, you can solve it and verify. Understand? So f of x is 1 minus x. Now we have to go back to this thing, g dash of x. What is g dash of x? F of x plus 2 whole power 15. So g dash of x is f of x plus 2 whole power 15 multiplied by x minus 4 whole power 6, x plus 12 whole power 17. X minus 4 whole power 6, x plus 12 whole power 17. This is your g dash of x. Now put the value of f of x in this. So then you will get 3 minus x whole power 15, x minus 4 whole power 6 to x plus 12 whole power 17. Now is the time when we have to use the wavy curve method. So you have to find a local minima and local maxima of g of x. So for that you have to find out g dash of x and express something like this, some form of this sort. So where you have the linear expressions in the basis and some integral powers. Alright, now you draw the number line. Alright, here x minus 3, the root of this will be 3. X minus 4, the root of this is 4. And x plus 12, the root of this is minus 12. Mark them on the number line. Now what you have to do, you have to start from the leftmost side. Alright, let us check the sign of this g dash of x. We are checking the sign of g dash of x. So when x is less than minus 12, when x is less than minus 12, this part is negative. Alright, this part is positive and this part is also positive. So this is negative, this is positive, and this is positive. So total it will be negative. So you draw something like this below the number line. Alright, now what you have to do, you have reached minus 12. So what is the power of this term? It is 17. Since it is an odd power, you have to go to the opposite side. If it is an even power, you will not go to the opposite side. You will be staying on the same side. Alright, if it is an odd power, you will go to the opposite side. Till where you will go? You will go till this 3. Now check for the power of 3. So the power of 3 is 15. Again an odd power. So you have to go to the opposite side. Something like this till 4. Now check the power of 4. It is an even power. So you will not be going to the opposite side. You will be staying on the same side. Alright, something of this sort. Now this is minus. This stays above the line, plus, minus, minus. So whenever there is a transition from minus to plus, so this is what? This is just the sign of g dash of x. Alright, the slope, what is g dash of x? G dash of x is simply the slope of g of x. So the slope is changing from negative to positive. So what we will have? We will have local minima there. And when the sign changes from plus to minus, we will have local maxima. So you let me know in the comment section what happens when the sign changes from plus to plus or from minus to minus. Alright, so let me know in the comment section. Now we have to find out, we have to count the local minima. So that is your p. So your p will be, this is one local minima. Alright, and that's all. There is only one transition from minus to plus. So the value of p is, sorry, they are not asking you to, okay, the question is not to find the number of points of local minima. It is to find the x coordinate of local minima. Alright, so you have to find the, so this p is local minima and your q is local maxima. Local maxima. So the value of your p will be minus 12. So that is where you have local minima. And for local maxima, the transition has to be from plus to minus, which happens only at 3. So your q is 3. This is the local maxima. Now you have to find out the value of modulus of p plus q. That will be your 9. Such a beautiful question it is. Alright. So initially you have to find out the function, the differentiation, the derivative of the function g dash of x, and then you will be observing that there is a term f of x involved here. So you have to take another equation which is given in the question, and while integrating that you have to be careful about this fact that you cannot directly put x into this thing. Okay, this is most important thing that you should do. And after that, eventually you find the value of f of x by solving the differential equation, and then what you have is your g dash of x. So then you have to use the wavy curve method. So do let me know what will happen when you have a transition from plus to plus and minus to minus in the comment section. And also do not forget to check out the end screens. So I solved very good advanced questions in the end screens. Alright, so that's all for this video. So if you like the content that I'm making, do not forget to share the videos with your friends, subscribe the channel for more such content, and give this video a thumbs up if it is worth watching this. And also you can join my Telegram channel through the link in the description. And if you have any queries, comment section is the way to reach out to me. Thank you. We'll meet you in the next video. Till then, take care.